Alright guys, welcome to today's class. Today I'm going to attempt the challenge problems for this entire chapter, alright? So let's get started with this question. 3141. The measures of two triangles of an isosceles triangles are 3x plus 4 degrees and x plus 17 degrees. Find all possible values of x. Alright, I won't delve into the answers, but the answers are pretty obvious once you consider two cases, alright? There's three possible cases, right? There's only like basically two cases. The one of most of them, one is like if one of them is base angle, or the second case is both of them base angles. If one of them, for the first case, if one of them are base angles, then we have x plus 17 is the vertex angle, or 3x plus 4 degrees is the vertex angle, and then you can solve from there. Alright. Secondly, for the second case, if we had 3x plus 4 is equal to x plus 17, if they're both base angles, then the thing that follows is 6x equals 6.5 degrees. Alright? So either it's 3x plus 4 is equal to x plus 17 degrees, or 3x plus 4 times 2 plus x plus 17 degrees is equal to 180 degrees. And finally, 180 degrees is equal to 2 times x plus 17 plus 3x plus 4. Alright? So you just gotta solve the equations and you get the three possible values of x. Alright? Now let's move on to 3.42. Triangle ABC is equilateral in the diagram below, and ABD, BCFG, and CHI are squares. Prove that triangle DFH is equilateral. Now, how do we go on about to solve this question? Well, a first thing that comes up to mind is triangle congruency. Alright? Let's see what we can find about the sides. Alright? Well, we know that CA is equal to AH is equal to BC, and a bunch of side length equivalents. Alright? So let's see what can we do about this. Well, what are about these triangles over here? CAH, as well as maybe let's look at these triangles. DAH. Okay, I think we got a good idea. We want to find some triangle congruencies here, right? To prove that these three sides are congruent, not the angles, but the sides, in fact. Right? It's like how do we find the angles? It's not hard. It's not possible. We're only probably going to use the angles for congruency purposes, all right? It's the only thing we're gonna. That's the only way we're gonna use it. So how do we approach this then? Well, we find similar congruent triangles, right? Note that CAH, ABD, and BFC are congruent. All right, these two angles are congruent. All right. Now from here, can we get from here? Hmm. Well, we have DA is equal to AHA and is equal to BF. Now, we want to prove that DBF, DAH, and HAF are equal. Well, since we only know two sides, there's only two sides that we know. We need an angle. That's all we need to do. We need an angle between these two sides. But that's pretty obvious from here, where the angle is. Well, notice that BFC is equal to... Wait, hold up. Any other angles? We got this side is equal. Let me actually draw it in red so I can see it better. And you can see it better. We got these side lengths. Where should the angle be? Well, the angle should be located over here. to prove our SAS. Or maybe SSS. But if we proved it by SSS, then we already solved it. Yes, AAS could be a possibility. But so let's see if we can do it by SAS. Well, hmm, let's investigate this angle. EAH. We're actually, I think we should investigate EAH because there's like a similarity over here, right? We're looking at EAD and EAH. Interesting one, right? Well, notice that EAH 360 minus DAH. Technically, oops, not DAH, it's EAH. But technically, it should be 360 minus the other angle, right? The over 180 degrees angle, all right? Which in turn is equal to EAB. Is a component of EAB, BAC, and finally CH. Alright? But these are pretty obvious what they are, alright? It's pretty obvious what they are. This is basically 90 minus 60 minus 90. Alright? Now what else can we derive from here? This just follows to be 120 degrees. This is 120. Looks like a good angle, right? That's like a 60-degree angle. And what can we relate now? Now, DAE is equal to 45 degrees. How come? Because this is literally a bisection. Right? This is literally a bisection. Let me clear up this picture. This is DAH is a DAH DA DAE I mean is 45 degrees because this bisects the angle in half, alright? Now what else next? Now what is DAH now? We can find DAH. Well, that's going to be EAH plus DAE or 165 degrees. This similarity can be applied continuously. All right. We can apply this similarity to the HCF and DBF, providing is congruent now. Now it's just going to be congruent through SAS. Or finally, DHF is an equilateral triangle because these three sides are all equal. All right. By SAS, this follows because we proved that DAH is equal to HCF is equal to DBF, and DB and BF is equal to DA and AH, and equal to CF and CH. All right, and the result follows. Right now, also on to 3.43. Let ABCD be a rectangle, meaning that all four of its angles are right angles. Construct equilateral triangles ABE and BCF externally on sides AB and BC as shown below. Prove that triangle DEF is equilateral. I'll ask you for trying this question and tell us what you have. All right, let's get started with this question now. So how would we approach this? I've gave you enough time to write the proof, but you could just give me a part of the solution, right? All four of his right angles construct equilaterals ABE and DCF external. Now prove that DEF is equilateral. All right. First thing that pops up to my mind is we can prove that it's isosceles. But how? Well, maybe it's isosceles. Yeah, it's isosceles. How? We know that these is 60 degrees and this is 90 degrees. This is 60 and this is 90. So from here, this follows that these two angles are the same as well as these two sides. All right. This is the side that, and then find the equivalences. So we know that ED is due to DF. Now, final thing is to show that one of these sides is equal to EF. How does that pop up to our mind? All right. How does that pop up? Well, EBF. Is there any equivalences we can get with this? Well, there is one. And that is proving that these two are the same. All right, we want to prove these triangles are the same. So this angle is very important. We already know that the side lengths are the same. There's two sides that are the same. Now it's up to the angle. We can angle trace and see that EBF is equal to 360 minus 90 minus 60 minus 60, which this is equal to 360 210 or 150. Same as these angles. So the result follows that this angle, this side is equal to that side is equal to that side. So DEF is equal out. Alright. Anyways, let's move on to 3.44 now. ABC has a right angle at C. Points D and E are AB such that AD is equal to AC, BE equals to BC. Find DCE. Let's get to trying this question and determine to chat. Well, let's get started with this question now. So how would we approach this? We have a bunch of medians. What is a medium? Median? Well, median is basically a line from a point that bisects a line, another said line segment, right? Now we have AD equals AC and BE equals BC, all right? And that's the medians. Hopefully that's a median. Oh yeah, it's not. Well, if there's medians, they're very important because of the stylings. But anyways, we have AD is equal to AC and BE is equal to BC. Find DC. We got isosceles triangles here, alright? Now let's first analyze AD and AC. AD and AC. This angle is pretty important, I believe. Let that be X, alright? Let that be X. Alright, so these two sides are equal. So this entire length is 180 minus X divided by 2. So is this. So from here, this is going to be uh since that's 180 minus X divided by 2, that would be 180 minus 180 minus X divided by 2. And this will be this will be 90 minus 180 minus X divided by 2. Alright. And then this is just 90 minus X. Is equal to 180. Alright. Well, that's equal to 180. Alright. So that knowledge is not gonna be helpful. Okay. What other knowledge do we have? What else do we also have under our belt? Well, we have BC and BE. Alright. This is X. This is 90 minus X. And we have this is equal to that. Alright. That's very important. Well, what's that? Well, that's just going to be 180 minus 90 minus X divided by 2 then. Agreed, right? That's going to be BEC. Now, since we want to find EC, DCE, and we know that this is going to be 180 minus X divided by 2. Do you see where I'm going? Well, since we know this is 180 minus X divided by 2, if we add this up, we lose all our X's, and we're left with 45 plus 90 degrees. Plus DCE is equal to 180. Solving leads to DCE is equal to 90 degrees. I'm at 45 degrees. Right? And that's our answer to that question. So purely algebraic manipulation can get you somewhere and can get you the answer, alright? Instead of angle chasing, you just chase with a variable, and then it'll just lead you to an answer once you seek out installation. Alright? Now let's go on to 3.45. Let ABCD be a square, and let EF be points such that DA is equal to DE to DF is equal to DC. And ADE is equal to EDF is equal to FDC. Prove that BEF is equilateral. Well, I'll let you guys try this question and tell them to chat. All right, let's get started with this question. So what can we do? We don't have anything that particular that's important, so we might as well just draw the lines out. I want to prove that these sides are all equal. Well, how do we approach this? Note that ADE is equal to EDF is equal to DC, and DA is equal to DE is equal to DF to DC. So DAE is equal to it's congruent to EDF, it's congruent to FDC. All three triangles are congruent. So this side is equal to that side is equal to that side. Now it becomes clear that what we want to prove is that AEB and BFC are isosceles triangles. That's all we want to prove. Now, how does it come to mind? How does this come to mind? Well, we can consider many ways. For one, if we want to try to do this, for one way to do this, we maybe want to draw a line over here. Does that help us? Well, we notice that ABD in this chart, we notice that BD bisects every single angle that's ABC. That's equal. We'll notice that this is going to be an altitude. So this is be 90 degrees, and this bisects it. So this is a perpendicular bisector. Alright? What else can we deduce? Well, if it's a perpendicular and it's the median, then this must be an isosceles triangle. This must be isosceles. These must be equal. Why? Because only you if say we have a random triangle. This is 90 degrees and these are equal. Notice that this is just telling you these two sides are equal, and only an isosceles triangle or equilateral satisfies these conditions. So we know that BE is equal to BF, right? But if these triangles are if these sides are equal, then this angle, these angles are equal by SSS. From here, we notice that this angle is equal to that angle, or AEB is equal to BFC. And then you get these two are congruent. Yeah, so these two are congruent. What else can we draw? So far we got a bunch of congruent triangles. But how can we find a way to make it so that we can force BE to EA? How does that happen? How are we supposed to force it to happen? That's the main idea of this problem, right? So maybe you want to find a difference in triangles now. Maybe this triangle. What if we prove that this triangle is equal to this triangle? AD, DAE, or EFD, or DFC is equal to this triangle. What is that triangle? Well, this triangle is BFA. And what happens if we find it out? What happens? Well, this just tells you that this angle is equal to that angle because this angle over here is equal to that angle, and as well as be 90 minus this, and this is also 90 minus this. So these are isosceles triangles, right? And that's how you prove it. Now that's a very important part, all right? We want to open our eyes to see what we want, what we're missing in this question. And that's we can draw a bunch of auxiliary lines. We already proved that a bunch of side lines are the same. So this should be simple. Notice that they both have the square sides. We can't find anything about the angles, but hmm. We do know this one is equal to that one. We do know that this is true. Alright? It doesn't quite relate to that though. Hmm. Well, it does relate to this though. This is hmm. Well, it actually doesn't relate to it. Oops. What else can we draw from this? Well, this one equal to side length, so we have this one angle, this side. Now all that's left is to find a side or an angle. All right. So we want to prove that BAF is equal to DAE, or BF is equal to FCEF or AE. All right. Hmm. Well, how do we get to that? Well, since DAE is equal to DE, DAE is equal to DAE, which we already solved. And then afterwards, we get DAE plus DEA is 180 degrees. All right. So how does this help us? This is going to be 180 minus ADE. Then we can show that this is also 180 minus ADE. I mean, this is going to be DAE plus DEA. Now, how does that follow? Notice that these is bisected. So this is 30 degrees each. All right. All right. Now, we can know that this is 30 also, and this is B. 180 minus 30 is 150 or 75 degrees, or resulting this into be 15 degrees. But then we can start angle chasing on this, all right? Oops. Yeah, so you didn't have, you could go on to prove BFA is congruent to DAE, and that would be it. But let's talk about angle chasing. I just realized we can do angle chasing case. It's gonna be 15 degrees. What is this angle? Well, that would be 75 plus 75 or 150. So this one's gonna be 210. 210. This is 90 degrees. This is also 15. All right, let's see. Anything else we can get from here? Hmm. Well, we do know that these two sides are equal. So let's say this is x and this is gonna be 210 minus x. 210 minus x and plus 210 minus x, which results in that's gonna be we have 180 minus that. Or 180 minus 420 plus 2x. Or this just results in 240 plus 2x. Minus 240, I believe. Yep. Okay, so from here, we get this is 2x minus 240, and this is 90 minus that. Hmm. So we get that this is gonna be half of this, or 45 minus x plus 120, or 165. And this is 165 plus x. This is 15. This I mean this is x. This is 165 plus x. Or 165 minus x. And this is 15. So from here you can deduce that this is gonna be 180 minus. So we're stuck. What if we then don't find it? All right. That's the entire tricky part of this question is just trying to find a great path for the angles. All right. So for this question, if we know we can use this, and we can find that BAF is equal to BAE plus EAF. All right. Well, how does that happen? Well, since EAF is equal to EAD minus FAD. Sorry, guys, we're going to go over time. It's going to be 15 degrees, all right? That's going to be 15 degrees since this is an equilateral triangle. So this is 30 degrees. So these are equal. So from here, you can deduce now this is an equilateral triangle and get the answer straight up. Or that this is equilateral, all right? So that's it for today's class. I hope you guys have a wonderful weekend, and I'll see you next week. Bye.